Whenever we have a problem with exponential solution, we convert it to NP hard problem as well as NP complete problem. This is one of the ways to deal with hard problems. Once a problem is proved as an NP complete problem, it ensures that there is no polynomial function exists to solve the problem. In absence of polynomial functions, it is difficult to solve such problems in the real world. Then how to solve or how to deal with these problems? There are few approaches where whenever we have a complex problem, we will consider a very simple algorithm where most of the restrictions in the input or the conditions of solving the problem are omitted. Second one, we will select a very simple instance of the problem space and we try to solve this problem. Once the simple instance is solved, then the bigger instance or complicated instances could also be solved. Based on that, there are three methods adopted for solving or dealing with NP complete problems. The first one is called the approximation algorithm, second one is called heuristic algorithm, and third one is called the probabilistic algorithm. So these solutions, these methods to solve the problem mainly focused on analyzing the best case and worst case scenarios, and then also sometimes by relaxing the restrictions imposed on the problem. It gives a solution which is very close to the optimal solution. But however, the solution provided by this kind of algorithms are not optimum, rather it is called suboptimum. In this video, we will explain about the approximation algorithm and we will see how this approximation concept is used in solving the NP complete problem. Moreover, we'll also have a discussion about differences among all these three categories of algorithm used for solving NP complete problems. Now let us analyze the approximation algorithm. As it is stated that approximation algorithm provides a near optimum solution rather than actual optimization solution. In order to derive the suboptimal solution or the solutions by the approximation algorithm, it relaxes certain expectation of the exact optimality of the main problem, and it guarantees a bound on the quality. Bound means, let's say y is the suboptimal solution and x is the actual optimization solution. So minimization problem deals with the minimum outcome or minimum result of the problem, and maximization problem deals with finding the maximum value of the solution. So if we can find the exact minimum of a solution and exact maximum of a solution, these are called optimal solution. However, the approximation algorithm do not provide the exact optimal solution. Rather, it gives a close to the optimum solution. If we consider an optimization problem either as a minimization problem or a maximization problem, the minimization problem says that we need to find the minimum of the result. And maximization problem, it deals with the maximum output. In case of minimization problem, it gives a close minimum. For example, if the optimal minimum is say x and approximation algorithm has given an optimal of y, that means y is smaller than x. Similarly, for maximization problem, it gives a result of y which is actually greater than the actual optimum value. So that is why the solution provided by the approximation algorithm is called the suboptimal solution. Approximation algorithm is based on mathematical modeling. That is, it models the performance mathematically and try to figure out the optimal solution. Also, there is a trade-off between the accuracy and the efficiency for any approximation algorithm. But however, the suboptimal solution is also very useful in order to find a close result of the complex problems, because the complex problems with 2 to the power n time complexity cannot be implemented in the real world. The performance of this approximation algorithm is measured in terms of approximation ratio. Approximation ratio rho plays a significant role in analyzing the approximation algorithms. Let us suppose that A is the suboptimal solution provided by the approximation algorithm and OPT is the actual optimization. Then approximation ratio rho is computed as the maximum of the ratio of the approximation result divided by optimized result, optimum result for minimization problem, and for maximization problem it is computed at the maximum of the optimum solution to the suboptimal solution. So this approximation ratio is a mathematical guarantee about the closeness of the solution provided by the algorithm. Means if I say y is the solution provided by approximation algorithm, x is the actual optimization, let us suppose that P is a NP complete problem. There is a two approximation solution for the problem P and denoted by A. So A is the suboptimal solution and P is the actual optimum solution. Now let's say P is a minimization problem. Two approximation problem A indicates that the result produced by A cannot be greater than twice of the value of optimum solution. It implies that A is not the minimum, but however it is close to the actual minimum. And how much it is close? It is said that the solution or the result given by A cannot be greater than 2 times of the optimal solution. For example, if A has actual optimization of 6 and we produce one approximation or the suboptimal result of y, then y cannot be great. It will be definitely greater than this value, but it cannot be greater than 2 times of this value. Similarly, if P is a maximization problem, then it says that for any value of n, any size of data n, the performance cannot be less, the performance given by A less than half of the optimal solution. Any NP complete problem such as traveling salesman problem, vertex coverage, minimum vertex coverage, 0 by 1 knapsack problem, all these problems can be solved by the approximation algorithm. But however, approximation algorithm is not only the method to solve or deal with NP complete problems. There are other two approaches. One is called heuristic approach and other one is probabilistic approach. In case of approximation algorithm, we relax certain restrictions on the problem or constraint on the problem in order to solve it. In case of heuristic algorithm, it is based on the intuition and this algorithm cannot be proved, but however, is always give the correct result. On the other hand, the probabilistic algorithm, it uses some randomized value or randomization strategy during the solution of the problem. For example, if we are not aware or we are not sure about some values of x, then we will take some random value and with that random value, we try to execute the algorithm. So this probabilistic, heuristic and approximation algorithm, they provides a close bound, although it cannot give the exact bound. That is why it is said that the solutions provided by these categories of algorithms are called suboptimal solution.